YAMK is a leading university of applied sciences in the area of technology and is located in Jyväskylä, Finland. It has a strong track record as an outstanding educator for bachelor's and master's of engineering. Its focus areas cover mechanical engineering, electrical and automation engineering, logistics and information technology, but also multidisciplinary applied sciences such as automation and robotics. Automation and robotics are one of YAMK's 6 areas of expertise. Robotics by YAMK combines YAMK's multidisciplinary skills in automation and robotics. Companies and organizations can utilize robotics by YAMK's testing, piloting, and simulation environments. We also help management and work communities to introduce robotics. The industrial robotics laboratories are located on our main campus. The laboratories cover many robotics-related environments and technologies. The latest environment is represented by a robot cell that combines traditional industrial robotics with the latest trends, collaborative robotics, mobile robotics, and 3D machine vision. The mobile robot serves the robot cell autonomously. The 3D machine vision system detects and locates objects for an industrial robot. The robot cell ensures the efficient and fast handling of heavy objects safely. When a person moves closer to the cell, the industrial robot goes into collaboration mode and slows down its speed. When a person enters the shared work area, the robot stops. And continues operating automatically when the person exits the area. The robot cell provides a wide range of applications for companies to test robotics. In training, the environment can be utilized for robotics, machine vision, and automation safety. Welcome to the robotics laboratory, Origo. The laboratory is utilized in engineering training and development and research with companies. The Mitsubishi Melfa RV2AJ 5-axis robot cell represents an older robot environment still used in robotics and machine vision teaching. The lab has mini robots for different manufacturers, for example, teaching programming. These mini robots driving on the table are M-Bots. The MIR100 mobile robot and the UR5 collaborative robot can be used separately or integrated together to collaborate with people. New robot technologies enable the moving of laboratory environments from one location to another, and if needed, also to company premises. The ABB IRB 120 6-axis robot cell is one of the most general environments in engineer training. The robot has 3 tools and an automatic tool changer. Training includes many simulation environments such as ABB Robot Studio and visual components. VR glasses allow us to see, for example, robot cells working in a car factory. This lab presentation is also done with visual components. Companies can test machine vision applications on a survey station. The survey station can be used to find optimal imaging geometry for a company's applications. The ABB IRB 910SC is a SCARA-type robot with integrated machine vision and an object sorter. The SCARA cell can be used to handle small objects, especially in speed-sensitive applications. Our 2 Techman collaborative robots can work together on 2-handed applications. The smaller collaborative robot can handle 4 kilograms, and the bigger can handle 12 kilogram loads. Both robots have integrated machine vision systems and electrical grippers. "3D printing is an essential part of our business research and development. Printing allows us to create entire tools for robots or jigs for applications. The laboratory environment also includes several machine vision systems, tools, and software for training. Here's a look at daily life at the laboratory. Environments adapt to the needs of education and business collaboration. For example, the bulk picking and stacking application of bricks for a construction company utilizes collaborative robotics and 3D machine vision. The 3D machine vision accurately tells the robot where to pick up the next object. The robot's vacuum gripper is designed to meet application needs. This example simulates a quality control and sorting of milling tools with a collaborative robot and machine vision. We want to sort blades automatically based on repair needs and size. The robot puts the item under the machine vision camera, which sends the results back to the robot. The robot's task is to place the object in the correct tray. One company needed to automate the assembly of hydraulic parts. Manual assembly is a tiring and time-consuming task that needs to be easier and faster. The goal is to pick up and put the O-ring into the plug. The application uses grippers and object handling in a versatile manner. Finally, the SCARA robot uses machine vision to ensure that the assembly meets the quality requirements. Mobile robotics has also been tested for company needs, for example, in logistics centers. We needed to find out how well modern mobile robotics can cope in a busy and challenging environment. Piloting often aims to support companies' investment decisions and risk management. The Agilux mobile robot, leased for this pilot, can lift pallets that weigh up to 1,000 kilos from the ground and move them autonomously to a predefined location. In one piloting of mobile robotics, we determined if the location of a search object could be changed dynamically. This kind of situation could arise, for example, if a person had moved the search object to an arbitrary location. In this case, we utilized machine vision and an LED marker to automatically locate the object. The client company is involved in developing an Internet of Robotic Things platform that allows robots and external devices to communicate. One issue to solve was robot positioning accuracy when picking up the waste container. Laboratories have also tested different types of exoskeletons to make human manual labor easier. Technology can improve well-being and efficiency at work, for example in production and logistics companies. Exoskeletons can be adjusted for each person and application. Versatile solutions streamline work, for example by facilitating squatting and standing. YAMC's field of automation and robotics is in close cooperation in a multidisciplinary manner with well-being and business units, among others. Robotics and new technologies are introduced to companies, taking occupational safety, well-being at work, and change management into account. In addition, YAMC works closely with equipment suppliers in the field. Finally, let's sum up YAMC's robotic laboratory environments. Robotics laboratories are utilized in a versatile manner for the needs of education and business research and development. The laboratories cover a wide range of robotics, such as mobile robotics, collaborative robotics, industrial robotics, machine vision, service robotics and mini-robots, and various simulation and programming environments. We do business cooperation with several industries, like the food industry, logistics, machine manufacturing, and construction products industry. Students do close cooperation with companies in the region through project and thesis work according to company needs. Thank you for your interest in robotics by YAMK.